Good morning, dear students. Yesterday class we discussed about the preparations of some important alcohols. So there are three important alcohols can be seen, the methods of preparations of alcohols. The first method of preparations of alcohol is from alkenes. From alkenes we can prepare important alcohols. So from alkenes we can prepare alcohols by which method? By what reaction we have to prepare the alcohols? By hydration of alcohols. By hydration of alcohols we can prepare some alcohols, and also we can get some mechanism. One mechanism is there that is very important for the point of examination, that is the conversion of alkene to alcohol. So conversion of alkene to alcohol, this is alkene, hydration of alkene. When we done the alkenes which when undergo the hydration process, that leads to the formation of alcohols. In the previous class already I discussed about that mechanism also. And second important method of preparation of alcohol is from hydroboration, oxidation of alkenes. So by this method also we can prepare alcohols. And third method of preparation of alcohols from carbonyl compounds. From carbonyl compounds. So these are the some of the important methods of preparations of alcohols from alkenes only. So this is except alkene, that is from carbonyl compounds. Already do you know that what is meant by carbonyl compound? The compounds containing C double bond O group. So this is the functional group is called as carbonyl group. This functional group is called as carbonyl group, we can say that. So first let us take the first method of preparation of alcohols from hydration of alkenes. So in the previous video I already done this preparation with mechanism also. Next let us go for the second method of preparation, that is from hydroboration, oxidation of alkenes. Hydroboration, what do you mean by hydroboration? Here the combination of hydrogen and boron which when undergo reacts with alkenes, that leads to the formation of corresponding alcohols. Okay, now let us take the reaction of alkenes with hydroboration, further followed by the oxidation, that leads to the formation of unsuitable alcohols. So let us take the second method of preparation of alcohol from hydroboration reaction. Next let us go for the carbonyl compounds. So when alkenes which undergo hydroboration reactions, and further that leads to the formation of trialkyl borane is the compound is going to be obtained. Further that trialkyl borane which undergo further oxidation with hydrogen peroxide, that leads to the formation of corresponding alcohols. So let us take the chemical reaction for the formation of alcohols by this hydroboration oxidation of alkenes. First I will consider alkene. So from alkene, when this alkene which undergo hydroboration reaction followed by oxidation, that leads to the formation of alcohol. That's why I will consider alkene. So alkene is, let us consider propene, CH3, CH2, CH double bond CH2. This is the molecule is called as propene. This propene molecule, the three molecules of propene which when undergo reacts with diborane. So which undergo reacts with diborane. So diborane is in the form of borane. So as you know that diborane means B2H6. Diborane is nothing but B2H6. Diborane. Di means 2, boron. So each boron having 3 valency. So 2 boron having 6 valency. That's why 6 hydrogen atoms. Only borane means BH3. Diborane means B2H6. So boron is having 3 valency. So 1 boron 3 valency, 2 borons having 6 valency. That's why B2H6 is the diborane. So I will consider the propene molecule which when undergo reacts with borane. So actually we consider diborane. Diborane is in the form of borane, I can say that. So borane is BH3. So here boron is acts as negative part, here hydrogen is acts as positive charge in this borane molecule. So when we add this borane molecule to this alkene, that leads to the formation of trialkyl CH2, trialkyl borane is the molecule we are going to get. So this is the molecule is called as trialkyl or tri, here propane is there, propyl, we can take tripropyl also, that is the trialkyl is general name. So common name, that is IUPAC name, we can consider tripropyl, we can say that. tripropyl borane. Tripropyl borane is the name of this molecule. So how you are going to obtain this molecule? So here the addition of borane molecule takes place to this across the carbon-carbon double bond. So where we have added the hydrogen and boron. Here hydrogens are the 3 hydrogen atoms are there. 3 hydrogen atoms which will add it to this carbon atom. So only 1 hydrogen atom if you add, so here 3 moles of propene is there, that will considered as, so 3 hydrogen atoms. So 1 hydrogen atom we have to add to this carbon atom, so that becomes, here 3 is there, here 3 hydrogen atoms are there. So if you add 1 hydrogen atom, if you multiply by 3, 3 into 1, 3. So 3 hydrogen atoms will satisfy here. So here CH becomes CH2. So next here CH2 it is as it is. So boron is negative part, so it is electropositive. We can say that carbon is electropositive, this is electronegative. So already I told you that this acts as electronegative, this acts as electropositive. So that's why this is positive charge, this is negative charge. So this molecule is called as tripropyl borane, we can say that. So what we want? We want alcohols from alkenes by hydroboration oxidation reaction. We have done hydroboration, means addition of hydrogen and boron is called as hydroboration. Next further is followed by oxidation. When this tripropyl borane which undergo oxidation, so in presence of hydrogen peroxide. So let us consider this molecule. This is CH3, CH2, CH2 thrice boron which undergo oxidation with hydrogen peroxide. Do you know that hydrogen peroxide is H2O2? H2O is water molecule, H2O2 is hydrogen peroxide. So we have to consider 3 molecules of hydrogen peroxide to complete reacts with this tripropyl borane. So what happens now? Now that leads to the formation of here alcohol molecule which will directly substituted to this electropositive carbon atom. This is electronegative, already I told you that, which when added, when we add this hydrogen peroxide to this trialkyl borane, this undergo dissociation and OH molecule will, OH is always electronegative. This is electronegative, as you know that electronegative substituent will directly substitute it to the propyl molecule. One second. Okay. Here OH molecule will substitute to this carbon atom. This is electropositive, this is electronegative. OH ion will attract to this carbon atom. Now what happens? CH3, CH2, here CH2 and directly one OH molecule will substitute to this carbon atom. What is left out? Plus here boron is electronegative, boron plus OH minus. How many OH minus ions? Here 3 to the 6 hydrogens are there, 3 to the 6 oxygen atoms are there. Now how many OH we have removed? 1 O and 1 H we have removed. So remaining, so 3 to 6, 5 oxygen and hydrogens are left out. So now we can consider, so BOH thrice. So here BOH thrice. Here 1 oxygen and 1 hydrogen we have removed. So the left out oxygen and hydrogen is OH thrice. So boron valency is also 3. Already I told you that boron valency is 3. That's why 3 hydrogen atoms are there. Here boron valency 3 hydroxyl ions which will come outside. So this is boron trihydroxide. So this is the molecule is called as alcohol. So this is the alcohol, is name of this alcohol is propanol. This is propanol. So this is the method of preparation of alcohol from hydroboration oxidation of alkenes. So first what I have taken, so alkene I have considered, from alkene which when undergo hydroboration reaction that leads to the formation of tripropyl borane, further which is tripropyl borane, further oxidation with hydrogen peroxide that leads to the formation of an corresponding propanol alcohol. So this is the method of preparation of alcohol from hydroboration oxidation of alkenes. Dear students, first you must write some definition for this preparation of alcohols from alkenes. What you have to write? When propene molecule which undergo hydroboration reaction that leads to the formation of trialkyl or tripropyl borane, further tripropyl borane which undergo oxidation reaction with concentrated hydrogen peroxide molecule that leads to the formation of corresponding propanol. This is the method of preparation of alcohol from alkene. So dear students, I thought you understood the preparation of alcohol from hydroboration oxidation of alkenes. So next let us go for the preparation of alcohols from carbonyl compounds. So the third method of preparation is from carbonyl compounds. Carbonyl compounds. So as you know that carbonyl compound, carbonyl, that is C double bond O, functional group containing compounds are called as the carbonyl molecule. From carbonyl compounds, which is the carbonyl group C double bond O. So either side any valencies can satisfy this carbon atom. Already as you know that carbon valency is 4, so 2 valencies are satisfied by this oxygen atom, another 2 valencies can be satisfied by any hydrogen atoms or any hydrocarbon or alkyl group. So either any one hydrogen atom or alkyl group can satisfy the either sides of valencies of this carbon atom. Okay, now can you give one example for the carbonyl containing functional groups? Carbonyl group containing functional groups, as you know that, so aldehydes, so aldehyde, what is the functional group of aldehyde? What is the functional group of aldehyde? Is it aldehyde containing carbonyl group or not? So guess it. And ketone, whether ketone containing carbonyl group or not. And carboxylic acid, whether carboxylic acid containing ketonic group, that is the carbonyl group or not. And esters, whether these ester molecules containing carbonyl group or not. Okay, so I thought already you know that aldehydes compounds are functional groups which consisting of carbonyl group. Why? Because RCHO is the functional group of aldehyde. So RCHO can also be written as RC double bond OH. So already I told you that C double bond O and either side of the valencies can be satisfied by either hydrogen atoms or alkyl group. So here this compound containing CO group, this C double bond O group is called as carbonyl group. So aldehyde is containing carbonyl group. Next ketone is R C double bond O R. This is ketonic function group. S ketone function group is also containing carbonyl group. C double bond O group, that is called as carbonyl group. Carboxylic acids R C double bond O OH. S it is also containing C double bond O. So carboxylic acid is also containing carbonyl group. Esters R C O O R. This is a functional group of ester. This can also be written as R C double bond O O R. So this is also consisting of carboxylic group. So that's why we can consider, so all these molecules functional groups are having carbonyl compounds, so that we can prepare alcohols either by aldehydes or ketones or by carboxylic acids or by esters. Now let us go for the preparation of alcohols from aldehydes, ketones, carboxylic acids and esters by reduction process, which when undergo reduction means addition of hydrogen in presence of suitable finely divided catalysts like nickel, platinum, palladium, rubidium, so like that. So those are the catalysts. By using such catalysts we can able to reduce these aldehydes, ketones and carboxylic acids or esters to bring about alcohol molecules. So now let us take the first one. So from carbonyl compounds by reduction of aldehydes and ketones, by reduction of aldehydes and ketones. When we reduce the aldehyde and ketone molecules, so that leads to the formation of corresponding alcohols. So now when aldehydes, which when react with hydrogen in presence of finely divided catalysts, that leads to the formation of primary alcohols. Similarly, when we consider the ketone compounds, when ketone compounds which undergo reduction in presence of finely divided catalysts, that leads to the formation of secondary alcohols. Keep it in your mind, this is very important. When aldehydes which undergo reduction, the addition of hydrogen is called as reduction, that leads to the formation of primary alcohols. So name the product obtained when aldehydes which undergo reduction reaction. So what is the product? The primary alcohol you are going to get. What type of alcohol you will obtain? So when the aldehydes which undergo reduction, if they ask to write for 1 marks, you have to write the primary alcohols. So whenever ketones, so name the product which obtained when ketones which undergo reduction. So that is the formation of secondary alcohols. ಇಲ್ಲಿ aldehydes ರಿಡಕ್ಷನ್ ಮಾಡಿದರೆ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ಫೈನಲಿ ಡಿವೈಡೆಡ್ ಕ್ಯಾಟಲಿಸ್ಟ್ ಜೊತೆ ದಟ್ ಲೀಸ್ ದಿ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಪ್ರೈಮರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರುತ್ತೆ. ಕೀಟೋನ್ಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ರಿಡಕ್ಷನ್ ಮಾಡಿದರೆ ನಮಗೆ ಸೆಕೆಂಡರಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಬರ್ತದೆ. ಸೊ ಹಾಗಿದ್ರೆ ನಾವು ಲೆಟ್ ಅಸ್ ಟೇಕ್ ಸಮ್ ಇಂಪಾರ್ಟೆಂಟ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಂಡ್ ಆಲ್ಸೋ ಆಸ್ ವೆಲ್ ಆಸ್ ಕೀಟೋನ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ಸೊ ಲೆಟ್ ಅಸ್ prepare the alcohols by the aldehydes and ketones. So I will consider one aldehyde molecule. So I will write one point. Aldehydes which undergo reduction to give primary alcohols, Similarly, ketones which undergo reduction to give secondary alcohols. Dear students, now I will consider one aldehyde molecule RCHO. This is an aldehyde which when undergo reduction with dihydrogen molecule in presence of finely divided platinum, palladium or lithium aluminum hydride are the catalysts. So such catalysts will improve the chemical rate of reaction, and by this addition of hydrogen this aldehyde molecule will reduce us to alcohol molecule. So the name of this molecule is alcohol. Generally we can consider it as alcohol. When we replace this alkyl group we will get the corresponding alcohol name. So let us replace CH3CHO. This is acetaldehyde. When this acetaldehyde which undergo reduction in presence of hydrogen, that leads the formation of, in presence of platinum, palladium and lithium aluminum hydride are the catalyst that leads to the formation of CH3. This aldehyde molecule which when undergo reduced in presence of hydrogen, so this is a reducing agent. The addition of hydrogen takes place in presence of finely divided catalyst that leads to the formation of CH2OH. The name of this molecule is called as ethanol. Dear students, I confirm that. So how we can prepare the alcohols? By the aldehyde molecules. So similarly we can also take the ketones. The ketone is RC+O+R. So this is the ketone molecule. So when this ketone which undergo reduction in presence of finely divided platinum, palladium, in presence of lithium aluminum hydride, that leads to the formation of secondary alcohols. Already I told you that RCOHR. So this is the secondary alcohol, CHOH. So this is the molecule is called as secondary alcohol. This is the molecule is called as primary alcohol. So this is primary alcohol. When the aldehydes which undergo reduction in presence of finely divided catalysts like platinum, palladium and lithium aluminum hydride, that leads to the formation of primary alcohols. Already I told you that when aldehydes which undergo reduction, that leads to the formation of primary alcohols. So similarly ketones which when undergo reduction with finely divided platinum, palladium, lithium aluminum hydride, that leads to the formation of a secondary alcohols. So this is about the preparations of alcohols from carbonyl compounds. So here also containing carbonyl compound, this ketone also containing carbonyl compound. So by reduction of aldehydes and ketones, so aldehydes ಮತ್ತು ketones ಅನ್ನು ಏನು ಮಾಡಿದ್ದೀನಿ, reduction ಮಾಡಿದ್ದೀನಿ. By reduction of aldehydes and ketones we can able to obtain the corresponding alcohols. So similarly we can also obtain from carboxylic acids by reduction of aldehydes and ketones, and also as well as we can consider from carboxylic acids. Let us consider reduction of carboxylic acids. acids. So now let us take the reduction of carboxylic acids. Reduction of carboxylic acids, that leads to the formation of corresponding alcohols. I will consider carboxylic acid is RCOOH. So which when undergo, consider the reduction reaction, that leads to the formation of an directly we can able to obtain in presence of lithium aluminum hydride, that leads to the formation of RCH2OH. RCH2OH. So this is the method of preparation of alcohols from reduction of carboxylic acids. So lithium aluminum hydride is the costliest to react with carboxylic acids to obtain alcohols. So due to costliest of this lithium aluminum hydride is costlier due to more cost of lithium aluminum hydride. First convert carboxylic acid into esters. Further esters are get converted into alcohols. So this is the best method for the obtaining alcohols from carboxylic acids. So directly we can also obtain carboxylic acids, we can treat it with lithium aluminum hydride, we can able to obtain such type of alcohols. But this is the very difficult to obtain the alcohols from carboxylic acid. Why? Because this lithium aluminum hydride is too much costlier. So that's why, due to more cost of lithium aluminum hydride, first convert carboxylic acids into esters. So means the esterification process. Further, the such esters are get converted into alcohols. So as you know that the conversion of carboxylic acids into esters. Let us take the conversion of carboxylic acid into ester. That is RCOOH. So this is carboxylic acid. This which when reacts with ROH, alcohol, in the presence of corresponding sulfuric acid, that is concentrated sulfuric acid. So as you know that when carboxylic acids react with alcohols in presence of concentrated sulfuric acid, such that leads to the formation of corresponding esters. This is our R dash. So I will consider RCOO R dash plus what is left out here, H is left out, here OH is left out. So H2O, so that will come outside. So H2O, this is sulfuric acid. Sulfuric acid is a dehydrating agent. Dehydrating agent means it is tendency to remove the water molecule. That's why this is water molecule is removed by this concentrated sulfuric acid, and ultimately that leads to the formation of a product is called as ester. So ester molecule which when undergo reduced in the presence of acid hydrolysis reaction, which will undergo acid hydrolysis, that leads to the formation of corresponding alcohols. Okay. So further this can be RCOO R dash, further which is undergo reduction in presence of hydrogen, or we can also use sodium alcohol. Sodium alcohol is the catalyst. By using sodium alcohol catalyst, we can get convert ester molecules into corresponding alcohols. That leads to the formation of RCH2OH and plus ROH. The alcohol is again come back. So this is the molecule is called as alcohol. So this is all about the preparation of alcohols from carbonyl compounds by reduction of carboxylic acids. So here the carboxylic acid which undergo reduction. So this is reducing agent. Lithium aluminum hydride and sodium borohydride. So these are all the reducing agent. Lithium borohydride, sodium borohydride are the reducing agent. So now we have used lithium aluminum hydride as a reducing agent that will reduce us to alcohols. So this method is very costlier to prepare alcohols. That's why further instead of this using lithium aluminum hydride, we are using